Hi, I'm Andres Spira, co-founder Custard. So one of the biggest challenges that we've been having as part of our workflow automation was how to integrate AI agents into our workflows and how to efficiently take advantage of MCPs to streamline or fasten our work processes. So we build agents that cut across from observability to SRE workflows, QA workflows, CI/CD pipelines, and recently we started integrating AI agents into uh, the user workflows. We use agents to automate claim validation processes. We use agents to check denials and run analysis on risk models for denials. So one of the things that, from an operational point of view, was more like how do we efficiently have full visibility into not just what the agents are doing, but more into the reasoning traces and also uh, the tools that the agents are calling through MCPs. And from an operational point of view, not looking at uptime, which are like the SRE portion of it, but looking deeper into things like how can we guardrails the agents and use the SRE principles that we use when we monitor microservices, when we do deployments on large scale distributed systems to efficiently have like full visibility into agents. So from an observability point of view is you typically have to do like a telemetry, you instrument your application, and then you have all these metrics that you are pushing from the application into the different observability tools, and then you build your own dashboards and alerting principles. So we use the same principles across all the agents. We instrument the workflows, we get elementary data, and we push all these metrics into dashboards that give us visibility into how the agents are performing, they're doing their work. And one key critical is agents are fast, pretty fast. You have one agent processing close to 1,000 to 2,000 to 5,000 requests in a minute or a second, and uh, that's like multitude of volume of data being processed. There is a lot of reasoning going behind what the process agent is doing and everything that is doing. So without clear visibility, like you are in the dark. It's more like you are running a EKS cluster that you even don't know what the pods are or what the pods are doing and everything that they're doing. So we wanted to limit all that, or we wanted to create that visibility for our team. So you're talking about the normal principles where you have the green dashboards 200, everything looks okay. Your agent is processing all these policy documents, giving user feedbacks, and you have zero understanding of why that agent is doing so, or why those recommendations are being given back to the user or a patient. And at the end of it, when you come to the aspect of audit trails and accountability, you need to have ways to trace back and say like, oh, this was validly given to a user, this was wrongly given to a user, and this is why. And there's the aspects of stale data where the agents are using outdated data to give back responses to the user, which might be a bit wrong. And so that observability gap is what we have tried to fill. And for us is one uptime production report. We don't just look at, oh, is this agent active, like reliability aspect, like is this agent actively processing responses. That's not the key aspect that we are looking for. We are looking at the reliability from an angle of, oh, is this agent correctly giving the user the correct responses that they're supposed to do, or is this agently correctly calling the right tool in the MCP. So we pushed all these metrics that we are pulling from agents into Prometheus, and then we build alerting principles and policies within Prometheus. So most of you, as you understand, with the aspect of LLMs, we have hallucination, we have agents like calling tools or trying to access unauthorized tools, and then you have to build guardrails to prevent bypass, probably for PHI data or all that. And then we have context looping, where the agent might stick in a loop and just keep on consuming your tokens. Then we talk about the wrong context, the agent giving the wrong context due to large volume of prompt. And then the agent are always confident with all the responses they are giving. And you look at them, sometimes 80% of the time they are off or actually 100% wrong with the responses they're giving. So those are some of the aspects that we've tried to build SLO, SLIs into all this, and then alerting into our matrix dashboards. So uh, the thing is the same. Traditional SRE, oh, we are looking at availability, latency, LRS, and all those. But then these are agents. These are not like normal microservices or API endpoints that you're just monitoring for all these performance metrics. But you want to dig deep into like a signal fidelity, like the evidence real and current. Is the agent using like the right data to give responses to the users, things like that. So why traditional SRE doesn't work here is more like you look at microservices as a lie, you're looking at availability, latency, error rate, and here we are talking about context freshness. This is more like availability, reasoning, we're talking about latency, decisions, we're talking about error rate, and then throughput, we're talking about reasoning quality. And then we've introduced like a calibration metrics, which are more like the reliability aspect of, oh, if the agent is 80% confident, is it really 80% confident with the responses they're giving? So the calibration problem, as I talked about initially, oh, most agents or most LLMs, they'll tell you like, I'm 80% confident that the response I've given back to the user is 100%. Oh, but if the agent is using stale data or stale information, that information is 100% wrong. And when the agent dives into a looping or hallucination, it ends up giving inaccuracy information. So we build a calibration modeling across the reasoning component within the agents that validates the information that the agent is using to give the accurate responses back to the user. So a couple of weeks or months ago, I was in one of the SRE talks, and we were talking about how the Bloomberg was scaling production, MCPs, and agents, and that was one of the things that I looked at it, and I was motivated to continue digging deeper into how we can expand all this work that we are doing on our side to have like a extensive metrics. So harnessing things like the context window to prevent agents from eating up or reasoning into a loop that eats up context and all those things. So the 9 principles that we picked up from the Google SRE playbooks, we automatically build this into MC agents AI workflows, and then so I'll walk through what actually works for us, like fidelity layer. We have the signal fidelity, context freshness, which is like how efficient the data is being updated, and then the reasoning layer, the groundness or tool authorization, and then guardrails compliance is the agent breaking the rules, like trying to call tools that are not supposed to be tool or trying to access data that is not supposed to be accessed. And then we have resource efficiency. You don't want your agents to be just eating your tokens within a looping, and then the confidence calibration. So we define the signal fidelity, how all the data is, and then you create a weighted score across it, and then that gives you an SLO and an error budget that you can use as best metrics within your alerting principles. And then we have the tiered precision framework, which is more like a agent acts autonomously, but then if that agent is being monitored by another agent, a guy, like a watchdog, we have another watchdog that validates the first agent's responses, and then if it validates to a certain level, it creates an alert that escalates that to a human being to give the final decision, final responses. And then you have like things like multiple window bandwidth alerting. So same thing, we are using the Google SRE principles to uh, check uptime, and then we validate this, or we align this with the reasoning components of how the agents are like reasoning, giving responses like the trace reasoning across the agent when they are analyzing data or giving feedback back to the user. So talk about the whole stack. We have Prometheus, we are pulling metrics from Prometheus, and then we have telemetry data, we are pushing traces to Jega, and then have our dashboards in Grafana. Then we have our alerting manager, which is more like having the SLO routing for within Prometheus. So you can have all this. These are just like how we are instrumenting the data flow into Prometheus. And then we have the SLI rules that, and then the confident calibration that we basically have within Prometheus. And then the alerting rules for reasoning gap in Prometheus, like severity, failure mode, and then the tool call and things like that. So let's talk about the error budget aspect. So we give an example of this process where you have an agent processing like a Medicare aid claim that uses like a 3-month old data that has not been updated to like the current policy or things like that. So 23 claims are being processed, and the agent is 80 to 91% confident on the 23 claims, and 19 of the 23 were wrongs. So we automatically flagged all these aspect within the agent call, agent tooling, and everything, which saved that a lot because these claims probably will have been submitted and all of them will have been denied by the payer because the payer had automatically updated the policies, but the policy the agents were using were a bit outdated. So what Sentinel caused was more like the flow, like, oh, claim being processed, claim the same pattern. It looks at the periodic historical data, and then Prometheus, you see the metrics were being, the alert were fired, and then we disable auto processing for the claims and all that. The error budget and the patient data was protected and all those. So without versus SLOs, the wrong decision being done. You have the impact, which is like the business side, and then you get a lot of denials in claims, and then the cost of doing resubmission and uh, resubmission of the claims is much bigger than the cost of just doing the initial claim submission. So it's better to build like a efficient process that allows you to efficiently catch all these errors before submission and end of this retrieval. So definitely right now AI agents are the some of the efficiently tools that you can use in production systems uh, uh, to speed up work processes and all those workflows, especially deterministic workflows. But they all come with their own limitations and their own hurdles that we from production system management, like from an SRE side, like it becomes a bottleneck, not from the efficiency of how the system is, but from the efficiency of uh, the knowledge lacking of how the agents or the visibility into what is happening within the systems. So with every problem, there's always a solution, and we are moving closer to tackle the issue of having agents observability as a key principle in SRE, and also moving closer to having full visibility into controlling how agents, audit trails, and all those information that we can capture from agents from a deeper point of analysis and also from a deeper point of view. I'll talk about how we've integrated all these metrics into Prometheus and into Grafana. So this is a sample Grafana dashboard that shows a visual representation of the agents fleet. Like we have a number of agents. You can see we are monitoring like token efficiency, calibration. So every time an agent processes data, all these metrics are being pulled from the agents, and then we are scoring them. We have the guardrails, and then we have the alerting metrics that we built. So we have like the reasoning quality budget, which is like a very critical aspect, especially when you're talking about using agents in regulated industry. You really want to have like full audit trails and visibility into what that agent is doing. So you really need to do a lot of quality metrics checks that allows you to have gated values that you can alert on from uh, from the user point of accuracy and things like that. So another thing, we talked about the cost of running agents in terms of token usage and all those. So that's also very critical. And then we are also monitoring how the agents and MCPs are interacting with each other and all those information. You want to see how the number of tools the agents are being are calling, and then latency and all those information. And then so this is like the beautiful part of the thing I love about this whole observability aspect is like you can narrow down to the deep down components of how the agents are reasoning to that level of building each individual agent, like sub agents that are being uh, streamed from the main agent. You can see how each small sub agent is reasoning, and then when they start hallucinating, when they start like consuming context budget, when they do all that, and then you can see how each sub agent is also using token efficiently and all those things. So same case when you talk about like an AWS cloud or Google Cloud, GCP cloud, you have a budget that you set aside for monthly usage and all those. So that's the same thing we are using. Like, oh, we are targeting certain amount of usage for the agents. So when they beat that threshold, we are start alerting. Probably there is a lot of hallucination or context switching within the agents, and then you can have agents in a context loop. So we also monitor that. You can see 7 common labels that appear. The agent is like trying to redo the same thing over and over, so that's being alerted. And then when you talk about hallucination aspects, you can also see we track all that information from the agent, and then we alert that, and then guardrails bypass, we also do all those things. Then you might find the agent is just like context switching, like from the original prompt that you basically gave it, and then it's now just trying to answer its own questions, creating their own scenarios and all those things. So we're also alerting on that to prevent wastage of token, and also giving like improper responses back to the user. And the aspect of like a user prompting an agent to do something that is the agent is not aligned to do, like, oh, you are using an agent in a medical context but someone is trying to do statistical calculation on the agent. So such types of information, and then you can narrow deep into reasoning chain for each individual agent, and then you can create beautiful metrics and also alerting policies on that. And then so all this, we are also having the reasoning quality observability. So as I talked about initially, like these are deterministic workflows. So we already have like a picture of what's correct and what's wrong in terms of the clinical aspect, or in terms of like a claim processing. You already know which code should be used where. So you have already set metrics that you are technically just looking at in order to know if the agent is giving like the right or the wrong context based on the information that is been given. And then you can see that you can see the SLOs and SLIs that we have set up for the different agents, and then the SLIs, the indicators that can show us how we are performing, how we are consuming all that information in terms of context and all that things. So all in all, at the end of it all, this builds upon uh, the SRE principles, and mostly taking advantage of the Google SRE principles and trying to build upon them on LLMs, AI agents, and models so that you can have efficient monitoring and observability platforms. So, for our side, we believe that observability is key, and without observability, it's more just like running a black box that you don't know when the next failure is or what the next failure is. So, yeah. So, thank you. I would like to acknowledge my team and also give warm credential to Komodo for giving me this opportunity to showcase and talk about how you can integrate all these metrics and observability into AI agents.